Hi guys, welcome to lesson 9.3, comparing functions with inequalities. Starting up on page 159. So we got a couple goals here with this lesson. We want to be able to graph and analyze functions on the same coordinate plane, which we've been doing a little bit of, and we want to be able to write inequalities to represent real-world situations. We've written a few to represent domain and range, so this won't be entirely new to us. Here we go with Axel and Anisa again. Axel wants to share a 900 kilobyte file with Anisa. Axel uploads the file to their online storage service so that Anisa can download it. Anisa's internet service provider claims that Anisa's download speed is 120 kilobytes per second, but Anisa knows that her actual download speed can be as low as 90 kilobytes per second. Write an equation that gives the portion of the file remaining to be downloaded, y, so that's the portion remaining, remaining to be downloaded, after x seconds of downloading, so that's going to be our domain, the downloading seconds, if the download speed is what the internet service provider claims. So, internet service provider says 120 kilobyte per second. And then we're going to interpret the meaning of the constant and the coefficient of x in terms of the context. So we're going to write an equation. So that's usually in a real life situation like this, it's usually going to be in slope-intercept form. So let's see, the file remaining to be downloaded. All right, well, the file size remaining to be downloaded is, it starts off being a 900 kilobyte file minus 120 per second according to the internet service provider. So when we're going to interpret the meaning of the constant, that's 900, that's the starting size of the file, and then the minus 120 is the amount downloading, let's say, downloading, can't spell, each second. So the reason it's negative is because this represents the amount left. So it starts out at 900 and it's going down by 120 each second as it downloads. So now we're going to write an equation that gives the portion of the file remaining to be downloaded, y, same as it was a minute ago, after x seconds of downloading, if the download speed is the minimum speed. So that's what Anisa said was 90 kilobytes per second. All right, so that would look like y equals 900 minus 90x then, in that case. And that's still the start file size to be downloaded. And this is the amount downloading, or download rate, right? Download rate per second. So now we've got those two, and we're going to put them both on the graph. So in either case, let's see, it's going by 20, 30, 40, by tens. Okay, so they both start at 9. Oh, wait. That's not going by tens. 100 is going by 60s. So this one would be 900 right here. And it's going to go down 120 every second. So that would be 2 60s every second. 2 batches of 60. So this is the fast one. And then the other one starts there also, but it only goes down 90 every second. So it would only be here. So basically 1.5 boxes each time, because each box is 60. All right, so there's my two versions. And it would be everything in between, so I'm fairly sure I won't be able to draw a straight line, but I'll try. So there's different amounts of the file that would be left. I guess it won't really go into the negatives. And it could be any fraction of a second, so we can connect those there. All right, so Anisa's download speed can average anywhere from 90 kilobyte per second to 120 kilobyte per second, as shown on our two previous graphs. And now they want us to, on the graph we made, sketch the vertical line x equals 3. So that's when the download time, is 3 seconds. And highlight the segment of that line. I don't have a highlighter in this program, so I'll have to use this. Highlight the section of that line that gives all the possible kilobytes remaining to be downloaded after 3 seconds. So this is kind of like on your embedded assessment. So we did that. And then we're going to say how much might be remaining. So anywhere from, let's say, that must be 540 to 660, right? Man, that scale's hard. So 540 to 660 kilobyte left. And then we're going to write it as an inequality. So the amount remaining, so let's call that R, I guess, would be between 540 and 660 left. The amounts you found in item 4B are the possible remaining amounts after 3 seconds of downloading, depending on her speed, as it fluctuates. So the line segment can be described as the set of ordered pairs x, y, where x equals 3, and the value of y is between the values indicated in the inequality we wrote. So y would be anywhere from 540 to 660. The download speed can average anywhere from 90 to 120 kilobyte per second, as shown on the graph in item 3. On the graph, sketch the vertical line x equals 5. All right, so that's here now. And highlight the segment that gives all the possibility of times after 5 seconds. So that would be this part here. How much of the file might remain to be downloaded after 5 seconds of downloading? We're going to explain it in words and as an inequality. So hopefully you can do this by yourself. I think it's really important, if you haven't already, that you pause, try it yourself, and then we'll kind of compare notes here. So that looks like it's from 300 to, let's see, well, 480. 480 kilobytes would remain. And as an inequality, the remaining would be between 300 and 480. Describe what the inequality and the line segment tell Anisa about the download. So the little line segment, the little highlighted part, I guess, and the inequality tell her all the possible amounts that might be left to download, depending on how fast it's going, after 5 seconds. So might be almost, might be more than halfway done, or maybe not, depending on if it was going on its fast speed or its minimum speed. So as I'm talking about this, if it's going too fast, or you need time to process, or you don't have enough information here to process, please talk to me. Speak up. You're not going to hurt my feelings. That's what I like to do, is explain it. Plus, somebody else most likely will be struggling with the same thing you are. So don't be afraid to ask questions in class if you need to. All right, now we're repeating ourselves here. So this is obviously something they want you to be strong at. So see if you can do this and interpret this, okay? And then listen. When you're done, listen back to it, but try it by yourself. So they want me to draw a line segment at 7.5 and how much of the file might remain to be downloaded after 7.5 seconds, and they want me to write it as an inequality. So it looks like anywhere from 0 to 240 kilobytes. The possible range of file left to download after 7.5 seconds is between 0 and 240 kilobytes. Let me know if that's not making sense to you. All right, so there's a region that could be filled by similar vertical line segments for all of the values of x that could be the times needed to download the file. And they want us to shade that region on the graph. So this is where a highlighter really would be handy, and I don't have one in this program. So all of the possible values for x all along the way would be everything in here. So if I shade all the region between these two lines, I'm going to find out all of the possible download time and remaining combinations that there are in this situation for this size file between these two different speeds. Oops. So that's what that would look like. I just unshaded it. So that's what that would look like. All the possible time, comma, amount left to download combinations in the story. Whew, this graph in item 3 is getting pretty full. At one time, Anisa's screen says that 180 kilobytes remains to be downloaded. All right, so that's her range. That's something on the y-axis. On our graph in item 3, we're going to now sketch the horizontal line that represents 180 kilobytes remaining to download. Well, that would look like this line. Let's see, 180. So that would be right here. Let's see, maybe I'll do black one. That would be this line right here. So maybe I'll just do it with dashes to help separate it. That would be that. And then it says, what is the equation of this line? Man, is that important. Do you know how to write the equation of a horizontal line? So here's the trick. Vertical and horizontal lines only have one variable in them, whereas most lines that are slanted have y and x, y equals mx plus b. If they're horizontal or vertical lines, they will only have the variable that is the axis that they cross. So picture a horizontal line. Which axis will it cross? You can see it crossing one of the axes right there. It crosses the y-axis. So the only letter in the equation will be y. And the equation will be y equals 180. That is the equation of that black horizontal line that I drew. And highlight the segment of the line that gives all the possible times Anisa might have seen this message. Well, that's all these right here, from here to here, I guess. And at what time might she have seen the message? So it looks like between 6 seconds and possibly 8.5 seconds. Between 6 and 8.5 seconds, because those values are in the shaded region between my two possible lines when the what was it, the when the file had 180 kilobytes remaining. Trying to use the right measurements here and stuff. All right, so This one says, now I'd love it if you just tried this by yourself first before you listen to me. And you would love it too, because you're going to get so much stronger, faster, smarter, and better if you do that. All right, if the download speed is 90 kilobyte per second, so I've got to know which of these two lines am I looking at. One was 90 and one was 120. The 90 is going to be the one that's not as steep, right? So that's this one, 90, because it would take longer to finish downloading. So I want to know which one I'm looking at. So if the download is 90, so I'm looking at that top line, how much of the file remains to be downloaded after 5.5 seconds of downloading? So 5.5 would be right here. And if I go up to that line, it would be right here. Use the graph or the equation to determine your answer. Well, that equation was y equals 900 minus 90x. And this looks like it's going to be about, let's see, 360, about 400-ish, right? Approximately 400 kilobytes from the graph. Let's see if we plug it in what we get. So after 5.5 seconds, 900 minus 90 times 5.5. So that would be, let's see, 900 minus 495. Well, we were close. That's going to give us like 405 kilobytes, which is more precise. But we could get approximate from the graph. Graphs are a lot harder to be precise on, depending on their scale and how accurate we can be. All right, so that should give you enough food for thought, and we'll pick it up in class. See you there.